OK, so I got asked to talk about what I have seen in the course of building Chef over the last 10 years. One of the things I've gotten is the blessing of being able to go out and see just a ton of different companies. And as I was preparing to give this talk, I was thinking, wow, what do I cut out? Because I got 15, maybe 20 minutes if I'm feeling crazy. And I realized I don't want to cut any of it out. I just want to be super nerdy and incredibly fast. You guys want to go with me? All right, let's be super nerdy and really fast. And so later, you'll be like, holy crap, what was that slide? And then it's fine. You can ask somebody, and it's cool. Or you can go on the internet, and you can look at the hour-and-a-half long version of this crazy talk and be like, God, I'm so glad he did it in 15 minutes. OK, DevOps. How many people here do DevOps? Raise your hand real fast. You got to go fast, though, because I'm running out of time, right? Like 4 people. I don't believe you. OK, so DevOps is a cultural and professional movement focused on how we build and operate high-velocity organizations, born from the experiences of its practitioners. What that means is DevOps is unique to the people who do it, right? It's born from the practice of people who did it. It's not a thing that we sat around and built on a spreadsheet. It wasn't like a thought leader paper, right? It was work that we were doing. And that means that it was different for everybody who did it. But we have a bunch of shared principles that come together. And the first one is DevOps is actually a thing that gets practiced by everyone. I'm a CTO now. I'm a systems administrator in real life. But everybody I know who works in a high-velocity organization practices DevOps. The important nut here, though, is that we're not generalists. It's not like I know how to do everything, and I'm great at it. In fact, what we are incredibly well-connected specialists. So when we talk about DevOps and cooperation, we're not talking about one team that does everything. We're talking about a bunch of people who communicate really well together to achieve their goals. OK, some of the principles of DevOps. The first one is we need to design for the safety, contentment, knowledge, and freedom of both your peers and your customers. If the people that you work for and the people that you do it for are safer, they're more content, they have better access to knowledge when they need it, and they're more free to make decisions, you're doing a good job. If you're not hitting these goals, then you're failing. People who are great at DevOps value these things in this order. It's people, then products, then companies, right? Not the inverse. And honestly, history for most of IT has been the opposite. People who are great at DevOps are lean. We try to eliminate non-value-added action. We thin out our processes. We prefer pull over push. We're doing continuous improvement. We're working in small batches and doing experimentation. We have an orientation to failure, which tells you that failure is normal, right? Rather than being afraid to fail, rather than building really complex systems that move really slowly with a high surety of success, if you actually got there, instead, we embrace the fact that systems will fail, and we get really good at recovering quickly. We embrace ubiquitous workflow automation. We look at the system and how it's supposed to flow, and we figure out how to make that system work no matter what. We are diverse. If we're building better software for our customers and for the world that we serve, it turns out the world is quite diverse and quite well connected. And so if our organizations don't reflect that external world, then the solutions we build will be wrong. OK, if you want to get good at these things, what do you do? Where do you start? The first thing is you have to declare your purpose. Write it down, make it public, say why you're here, what you're trying to do, include the people you're trying to help, the product you're building, and the change you want to see in those people. Then you need to write down your beliefs and what bring about good outcomes. How are we going to achieve this thing? If we behave this way, good things will happen for us. Mix in the things that are unique to your industry. If you're a bank, mix in being a bank. If you're a grocery store, mix in running a great grocery store, whatever it is. One of our beliefs is that we build software for the people who use that software, so we do the thing that's right for them, even if it's harder for us as developers. You need to build empowered teams. These are teams that have permission to act, paired with the context they need to make great decisions, and leaders who care about your purpose and share your beliefs. Then you're going to go out and form diverse bonds. You're going to take people out to lunch who don't do what you do. You're going to go, how many people here know your corporate lawyer? Way more of the room than knows about DevOps. So that's awesome. OK, so maybe what you should do is take your operations guys to lunch, just as a thought. OK. Then you're going to use those bonds to build consensus on important decisions, right? You're going to circulate your plans with some stakeholders. You're going to incorporate their criticism, their feedback. You're going to present back to the group. You're going to ask for consensus. This doesn't mean that consensus drives every decision, then your decision-making is mush. What it means is that you're involving people in the conversation before you make the right call. You're going to develop products that have strong value propositions. Strong value propositions are things that cause pain to go away, not vitamins. If your value proposition is eat your broccoli, that's a shitty value proposition, right? You need to make things people love, and you need to focus on things people need, not things they want. We'll get to this later. Then you're going to build a roadmap. You're going to start with your vision for what you think needs to happen. You're going to align it with customer feedback. You're going to balance that with the innovation that you have. And you're going to group that stuff into themes with an outcome for each. And then those are going to become features. The themes of your roadmap should hold. If you did it right, they won't change. Your outcomes may or may not change as you go. The features will absolutely change. You will totally be wrong. You need to always include delighters. This is a thing called the Kano Model. A good example of a delighter is if you were going out and interviewing customers about how to build a code review tool, no one would ever tell you that your code review tool needs to include the ability to put cat pictures in it. But anybody who's ever done code review with the ability to put a cat picture in will never use a tool that doesn't let them put a cat picture in ever again. That's a delighter. OK, you need to build features iteratively. One example here is you want to paint the Mona Lisa. So you decide to start with her head, and then you put it in her arm, and then you put it in her other arm. But that's not how it works. Instead, you say, I want to paint a picture of a woman in a pastoral setting. You build a sketch. You put it in a wash. You decide you like the colors. Then you finish the Mona Lisa, right? You have to build the whole thing, sketch it out every time. Iteration happens if you do it more than once. You need to manage your risk by doing it in small batches with near-term hypotheses. I want to build a sketch of the Mona Lisa, right? Near-term, small thing, be done in a day, right? Validation comes from customers, showing them the Mona Lisa and going, hey, you like the sketch? And they're like, yeah, but it needs some colors. You're like, yeah, no, duh. You're introducing near-term volatility in your plan, right? So you're going to change more often. But what you gain is decreased long-term risk, right? You're more likely to build the right thing because you're doing it in smaller pieces and you're getting more constant feedback than if you were to batch up over the course of a year and then just drop it on people and pray. You're not going to worry about scale. You don't have a scale problem. How many people here work at Facebook? How about Google? Amazon? OK, nope. Nobody here has a scale problem. Suck it. Now, someone in this audience said to themselves, but Adam, yes, I do. And OK, maybe you do. You don't. OK. You're going to get into arguments about execution. Mostly, you're going to argue about theory. You're going to be going along doing work, and somebody's going to come up and be like, I think your plan is a bad plan because of theoretical thing X or Y. And you're just going to be like, wow, that's so interesting. You know, I'm going to just keep working. And then we'll see how that goes, because we don't have scale problems. OK. Every week, you're going to demo your progress, right? Which is part of that killing the theory argument. Every week, you're just going to show everything that's happening to anyone who cares. You're going to invite everyone in the whole company. You're going to record it, and you're going to post it internally so they can see it. You're going to choose programming languages and tools that fit the job. How many people here are software developers? 2 guys. OK, so we're polyglots. The rest of the room, you know, software. It's awesome. The people who work for you that do this, they're polyglots. You should choose the languages that fit the job and work in small batches. You're going to use source code control, or your teams are going to use source code control. You're going to have a bug database, and you're going to triage and prioritize those bugs, and you're going to be nice to your customers by trying to fix them. You're going to do continuous integration. Continuous integration is about actually integrating work back to master constantly. It's not about testing every time you make a change, although that's true. But really, it's about having short-lived iterative branches that merge back into the mainline all the time. If it breaks, you need to fix it. The important part here is you're integrating into the mainline, right? You don't have long-lived branches that are off doing stuff for months and months. Instead, they're constantly folding back into the system. You're going to obey the rule of 4 eyes, which is nothing happens without 4 complete total eyes on it. You know, there's a problem with this, which is that some people have 1 eye. Just let it go. 2 people. OK. You're going to write tests. And you're going to write them one at a time. You're never, ever, ever going to start a project that says, we're going to spend 6 months writing tests. It's a stupid project. You're not going to run that project. Instead, you're going to write 1 unit test, 1 integration test, 1 functional test, and 1 smoke test at a time forever until you have good test coverage. Cheers. You're going to do continuous delivery. Continuous delivery is about being ready to ship if you needed to. So if the business needs to ship, can you ship? That's it. TLDR, be ready to ship, right? OK. You're going to have 1 path for change. So the way change moves through your organization needs to be fixed. How that gets implemented can be very flexible, right? So flexible at the level of execution, but when we talk to each other about how software gets to customers, there should be 1 way that it does that. And it should reinforce your principles and aid your flow. Code goes through the same workflow no matter what it is. Applications are code. Infrastructure is code. They should take the same path to production. You're going to focus on your availability. Availability is uptime over uptime plus downtime. And you're going to focus your efforts on reducing the mean time to diagnose a failure and the time it takes to repair it. Failure is inevitable. It's how you detect and react that matters. You're going to collect metrics from all sorts of different pieces. You're going to use the highest resolution you can get with as few systems as possible. You're going to make a plan for your capacity. You're going to identify your key metrics. You're going to put them on a graph. You're going to set a limit. You're going to plot a trend line and expand your time horizon to see when that thing exceeds the other thing. And then you're going to decide when and how you should have more infrastructure. Autoscaling will not save you. Autoscaling is an outage, right? It's just a fast response to an outage. OK, no autoscale. I mean, autoscale if you want, but plan. Love God. OK. Only alert on what is actionable. So get the attention of the right people with as few alerts as possible. I'll tell a quick story. I was a systems administrator. I was on call. I took a new job. It's my first on-call rotation. I still had a pager because I'm old. And it paged me at like 3 in the morning and said, it's happening. And I was like, what's happening? And then I got my coworkers or whatever on IRC, because again, old. And they were like, yeah, that page is funny. In 10 minutes, there'll be another one. And I'm like, what do you mean? And in 10 minutes, I got another page, and it said, it's happening, ... again. No one knew what it was. That page only stopped. It happened every once in a while for reasons we couldn't explain, and it stopped when we decommissioned the data center. Don't do that. OK, you're going to practice incident response. This is the OODA loop, John Boyd. You should look it up. The step that matters most is orientation. When you see a problem and something's wrong, orient yourself to that problem based on what you know about the system. Then you're going to practice incident response. Whoever it is that first learns about the incident is the incident commander. They decide what to do next. They coordinate resources. They communicate status. And it's not about rank. So if they happen to be the lowest level person in your organization, they're in charge until they decide they're not. Incidents lead to postmortems. Every time you have an incident you didn't expect, you're going to talk about why that incident happened and what you can do differently. You're going to use the principles of scalable systems design. That guy behind that is Mark Burgess. He's the guy who wrote CF Engine. He's one of my personal heroes. He should be one of yours. And he has a great theory about what's called promise theory. And essentially, you're going to think about your systems as autonomous actors who are responsible for their own behavior, that try to make progress toward their goals with clear promises to each other. And you're going to have those actors evaluate the quality of those promises. We could have a long talk about doing this. TLDR, try to make your systems work like people. Talk about intent and talk about boundaries. This is basically the same sort of thing that we've been talking about since the 70s, but not doing very well. Have a little bit of humility about your code, about your position, about your knowledge. Because we're a bunch of well-connected specialists, you'll be working a lot with people who are much better than you at what they do. When you're writing your code, you're going to focus on simplicity, extensibility, and reuse. Simplicity here can be misled. You want to take complexity. It's simplicity for the user, not for you, right? So there may be deep implementation complexity. If the end result is super simple for the user, take that every day, twice on Sunday, right? And then you're going to take everything I just talked to you, and you're going to find a business problem, right? You're going to go into your business, and you're going to be like, OK, what's one project we could do in 8 weeks that we can iterate on? And we're going to grab all the different stakeholders from all across the organization, lawyers, security, software developers, networks, systems people, sales guys, marketing executives. And you're going to do what I just said. You're going to look at your problem. You're going to figure out what your purpose is and how you're trying to solve it. You're going to come up with a roadmap for what you're going to do. You're going to iterate on those features. You're going to do continuous integration. You're going to do continuous delivery. You're going to do all of that stuff. And in 8 weeks, you're going to demo every week. And then in the end, you're going to have this business result you can look at. And you'll know what it feels like to actually run a high-velocity DevOps organization. All right. The important part here is that DevOps is an actual real thing. It's not just a word that someone made up. I mean, Patrick Dubois did make it up. But it's actually a thing that people have been doing for a long time. And I know that thing when I see it, based on those principles I talked about earlier and the behaviors that we've seen here. And I practice it by doing these things. And I apply it all the time in my daily work. And you should, too. And the last thing to remember is that I am unique in my own practice, right? I have my own experience. I have my own things that I have done over the last 10, 15, 20 years. And because of that, the way I do it is my own. And you will go and find your own way to do that. And when someone tells you you're doing it wrong, you can just remind them that there was this dude I saw once on stage with a big beard who told me it's fine. Thank you guys so much. It was great to be here, and I hope you enjoy.